Remember how if it's 95% for the whole thing, that means this is 47.5%. I've already got 34%, so it's 13.5 there between -2 and 1, or -2 and -1. And what's between 1 and 2?
13.5.
13.5. There's symmetry there. That's the beauty of it.
You make me feel smart.
I'm glad. It's not true for everybody, but I don't try to make people feel smart.
So we just hurt my feelings.
Dang, why you gotta come employ like that?
Exactly.
He may kick me. You deserve it.
Sounds like, never mind, I can't say that. All right. What?
Big show. You should have said what
I
you
mean,
were saying.
Just say it and then edit it out the video.
it sounds like you already know, but so
Wait.
He's so lost.
don't worry about it. Okay, so then what's between -3 and 3?
2. No.
Thank you. 99.7.
What?
What?
Oh, true. I didn't see that. Pay attention.
So 99.7%. But then again, I'm just going to focus on half of it for now, right? The lower half. So what's half of 99.7?
That's offensive.
49.85.
Thank you. 49.85. What percent have I already accounted for?
Sorry, 47.
47.5. So then what percent is going in this little tail right here? 2.35%. And then this upper tail? And so I want you to also notice, is there data outside of -3 below and 3 above? Yeah, we've only accounted for 99.7, right? So 0.3% is outside of that.
This is funner than the last one.
This is funner.
This is funner, guys. Roll Tide NASCAR. So moving on from there. So the empirical rule applies most accurately to population data rather than sample data, and I will agree with that. But what you need to know is the 68, 95, 99.7, and then how to use that. Hear me clearly on this. You might want to write this note to yourself. Know how to use that to figure out these little groups. Because I'll go ahead and tell you, there's no way on God's green earth I'm memorizing all that. But I can use 68, 95, 99.7 to figure those pieces out. Okay? Know how to use the empirical rule to break those different sections down. Oh, and I meant to skip this page, and so I forgot. I accidentally skipped the other one.
I got it now, but I'm understanding. Shut up.
All right. So, what are your questions before
Explain it.
I continue forward?
I have a question on.
That's
easy. That's easy for real.
The next page, yes.
24.
Hold on, I'm trying to pull up where we are now. We're supposed to be on page 25. Yeah, so skip page 24.
Can I take a picture of that? Because I keep doing it wrong.
Say again.
Can I take a picture of that?
I will leave it up here so that you can take a picture after class. And if I forget to, then remind me and I'll redraw it. Well, that's true. It is also on the video. It's not super easy to see on the video, but it is there. Okay. So here we are on activity 2.2. Apparently I skipped number 1. What am I doing with my life? It's fine. I don't know.
What are you doing with
That's what I'm saying.
Okay.
Okay. So all we're doing right now with these 4 is, please pay attention, you're stating whether the distribution shown represents population data or sample data. Then determine each percent, shade the corresponding region under each normal curve, and explain your reasoning. So let's do one of these together. What percent of the data is greater than the mean? So just let's look at this curve. Does anyone know if this is for a population or a sample?
Sample.
Well, you just guessing? Because that was a really quick reaction.
Population.
Do you have a reason for saying sample, Madison?
Oh, wait. Population is a little symbol.
What little symbol?
Sigma.
You see that sigma down there?
Yeah.
Sigma is a parameter, meaning it goes with a population. So then what percent of the data is greater than the mean? What we want to do is shade. So here's the mean, and where would I shade?
To the right.
To the right? Everything above? So what percent is that?
50%.
50%.
Yeah.
Complete
B, C, and D within your small groups.
Alright, I got
Wait, why did you,
Wait.
what made you cut it in half and shade it?
Because directions, what percent of the data is greater than the mean? Remember, 0 is the mean, and greater than the mean.
This ain't gonna be my first year.
What does the question ask? Percent of data greater than the mean, right? You recognize that's the mean? Which direction would you shade to get the stuff that's greater than the mean?
Or is that negative?
Well,
Is that?
think of, hold on a second, just think numerically in a second. If you have a number right here, how would you go to get greater than that number? Would you go to the right or to the left?
Well, it goes across the right.
Right.
Is that?
Aren't, isn't that to the right?
Yeah, but is that why you did that?
Well, I know that if I'm looking for greater than, I go to the right.
Okay.
Right?
Yeah. Okay. Oh, no, I didn't know if it was behind it or.
I mean, it's just the mathematical idea of greater than.
No.
But also, don't forget, what does 1 mean? 1 standard deviation above the mean. 2 standard deviations above the mean. 1 standard deviation below the mean.
Okay.
I want to go greater.
Wait. And she should have 60.
How you moving this second one?
Yes, ma'am. Y'all talked about it first?
You
might share friends.
Shut up. You said
Yep.
what? Listen.
What you said?
No, that's not, between the mean and 2 standard deviations. But where do we see 2 standard deviations below the mean? Right, where do you see the mean? No ma'am, the mean. But that's not what you're supposed to do. Right, so you want between here and here, right? So you're just getting this. How do we figure out that percentage?
I bet we play hide and seek.
Well, no.
This is one standard deviation.
So you should use half.
That's 35.
Half of what?
Or this is another standard deviation.
No, everything to the right is 50. What is your empirical rule? So, listen to my question. What is your empirical rule?
That's
No, empirical rule. We wrote down the percents that go to the empirical rule. It's right there on your page. No, you've written it right there.
You read the board, read the paper.
But answer the
What's the empirical rule?
It's right here.
For 2
This is why I get frustrated. You wrote it. You wrote it right here.
Like it's percentages, everything is
No, I cannot say you wrote it anymore.
Some of them are just not listening to my question.
No, you're not.
I literally only.
What is it? No, that's not it.
Don't touch
The thing I circled, 68, 95, 99.7. No, that is the rule. And once again, what did I say? You wrote it. I didn't say it's written on the page. You wrote the empirical rule. So, when we are looking at within 2 standard deviations, what percent is within 2? Okay? Now, do we have all 95? It's not. Because it's within 2 standard deviations. How much of that 95% do you have?
So, since this specifies
What
just
you need to
for
recognize. That's why we wrote out and wrote down the normal distribution. Use that.
it would be
No,
above
use a
it.
calculator.
Exactly. So this is just just below.
95%, right? Divided into 2, which is what?
So it's between above the mean, this is below the mean.
We did just do that, didn't we?
See, I mean, no, I'm
I know,
not, me, I
you should
heard
practice.
different.
Yeah, we talk through proof again, we're not reading what B says. What is,
Between that
instead of
and
getting
where's
frustrated,
This actually probably.
talk with me. Talk with us, talk with us. So what does it say? Between what boundaries?
I'm not writing out a paragraph.
I'm just asking you to read what question B says.
Between
I appreciate your apology. I'm sorry I got frustrated, but I want you to listen to my question.
Where's
But,
two
yeah,
standard
we're looking between what?
the mean and standard
So
deviation.
you're good with that's the mean?
more than that.
And it's not 2 standard deviations, it's 2 standard deviations.
Below the mean.
So where would 2 standard deviations be negative mean?
So draw my line at two
Just
standard
negative
deviations.
two.
No, that's what we're working from.
So just in between.
And
So
it
yeah,
says
that's why.
more than this. So which
Talk to your group about how to get that, but that's why it wasn't a negative one.
You told me you get the big house too.
What are your questions about that?
Okay, so let's say two different things we all got. So we're looking at,
Remember how we broke it down earlier?
Deviation.
So it's that way.
so where's two standard deviations?
I'm sorry.
Okay, so it's saying what percent more than the mean? So what would it be?
No, I need you to say, like, you don't have like your understanding, but you just sort out my class because you keep falling asleep.
Nothing, you've been cooking you. I haven't been teaching you.
Guys, we want you to talk a little bit more today. You haven't been talking a little bit. I said as much as she's been. What? I'm talking about your whole class discussion. Not as much as you've been. Okay.
So use the percentages on the.
Have you talked with your group?
Yes, he's broken down what percent is
Wait,
it? Each standard deviation, use those and all you're doing is add.
It's close to right.
So, let me guess.
Because let's also remember, isn't there a point 3 that's beyond here? Further, so there's another 0.5
It's not the whole thing.
beyond that, so maybe 2.5%.
Look at this, this is right here. You're looking at it. Are you sure that it's?
But here's the thing, what is the hassle? It is more than 2 centimeters below, right? So here's 2 centimeters, I guess we might, which direction should go to be more than 2 centimeters below? To be further to the
No, yeah, that's 68.
if you're more than, aren't you getting further away? Further away to the left. Thank you. Thank you. We're gonna break down B and C so you can get back to D and go through it. So you can get one more practice problem. So B, what percent of the data is between the mean and 2 standard deviations? So mark the sections, which I think we're getting, as far as I can tell, we're pretty good at. Make sure you read the question. And remember, we already broke one of these down, or how to do the entire curve, which is what you're trying to do at this point. What I would keep in mind is, what's between -2 and 2? What percent is between -2 and 2? 95%. Guys, I cannot emphasize this enough. I literally wrote it up here. The empirical rule is that 68, 95, 99.7. You need to know those 3%, and then we can use that to break it down. So if 95% is all the way in between, what's just this part, this half?
47.
Right.
This is easy.
Girl.
I'm so glad you're now thinking that way.
I had been stressing out for like 5 minutes
You were getting way too
Seriously.
stressed out for me.
Because you did.
How about we just keep going?
I feel like I'm in a meme right now, where I'm just blinking at you hardcore. Okay. So C, what percent of the data is between 1 and 2 standard deviations above the mean?
13.5.
So here's the 1, here's the 2. Now here's the thing. Are you going to memorize that?
No.
No. So you would probably need to be able to break it down. And what I would do is I would again, all right, I'm going to break this down. How much is between -2 and 2?
95.
95%. But I'm only going to now look between 0 and 2.
So it doesn't even happen.
So that's at 47.5. And then what's between 0 and 1?
13.5.
0 and 1.
Oh.
So remember that's 34%, which is why we know if this is 34%,
That's 13.
I need 13.5 more percent for that 47.5 total. So again, notice I'm breaking it down into those parts. And that's not the only way to do it. You could have broken down -1 to 1 first and done 34 and 34 and then figured out that piece. But you're splitting those into the halves and those different pieces. What's your question, Madison?
Oh, nothing. I'm messing with this.
Oh,
Now, the next wording is a little confusing, so I need you to pay attention to this. What percent of the data is more than 2 standard deviations below the mean? So where's my line going to be? At the -2. Everyone seemed to be okay with that.
Yeah.
But if it is more than 2 standard deviations, that means is it closer to the mean or further from the mean?
Further.
It's further, so it's going to go to the
No, I just gotta pass it through.
Oh.
it's everything to the left. It is more than 2 standard deviations below the mean. The idea of more is further away. Please hear me again on that clearly. More than that below the mean means that it's going to be further away from the mean. Okay? So it wouldn't be the 2.35. That's very close. Madison?
2.65.
Very close.
Just go with stupid.
Let's pause for a second. Why are you thinking 2.65?
Because it would make up a whole.
Because what percent were we missing when we did the empirical rule?
0.3.
0.3. But remember, here, or to the right here, and to the left here is 0.3. So what percent's right here? 0.15%.
True. Yeah.
Okay? An easier way, so hold on, an easier way to recognize it is this. What percent is between -2 and 2?
95.
95%, right? So then, what percent was between 0 and 2? 47, or yeah, between here and here is 47.5, right?
Right.
So what is the tail here that I'm missing?
3%. Wait, what?
Yeah, 2.5.
Remember, isn't it half is to the left?
Yeah.
And then we all recognize that between 0 and -2 is 47.5, right? So what do I need to add to it to get to 50?
Oh, true.
2.5. Which notice that is this 2.35 that we already identified. And then if I include the 0.15 to the left, I get 2.5%. Right?
So it's
99.7, but you need that 0.3. 0.15.
0.15 is here and 0.15 is here. Right.
So you need that to make that 3.
Right. Okay. What's your question, JC? So, say it one more time.
Like, this is like.
Yeah. It's 2.5%. 2.35 plus 0.15% is 2.5%.
So
Okay. I'll get to you in a second. So what are your questions? I'll get to you in a second. I don't know. Okay. All right. I hear side conversation, so I'm moving on. Again, another thing to keep in mind is what percent is in between -2 and 2? 95%, which means what's remaining on these tails if 95% is in the middle?
5%.
5%, but if I split that 5% in half, I get that 2.5%. There's lots of ways to see it, okay? You just need to be able to figure out how to get there. Alright, and this is what, so this is where,
Bless you.
Sorry.
Oh, God, I'm trying.
Playing games.
come on, Mark.
Yes,
Alright, so here we go. This is where we should be, or where I finally actually have correct slides. And so we can now use this to actually look at real context, heights of adult males. So consider each normal curve. State whether the distribution shown represents population data or sample data. I forgot to write that on the previous one, but we'll do this here. Then determine each percent shading the corresponding section. Alright? So, first off, A, population or sample?
Oh, yes.
Population.
Population.
Why are we saying population? Because I heard you first.
The sigma.
The sigma, it's not just the sigma, it's also the mu. Remember, both mu and sigma are used as parameters for a population. Okay, so we're looking at a population here. And then we want to know a percent of adult males who have a height between 62 inches and 74. That should be nice and easy to recognize here and here, right? And so we want that percentage. How am I supposed to figure that out?
The empirical.
We're going to use the empirical rule. Notice how 62 corresponds to 2 standard deviations below the mean? I mean, it's not sure, like, it's there. It says -2 sigma.
Yeah.
2 standard deviations below. The 74 is 1 standard deviation above. Well, remember, this is where we need to be careful. 95% is between 2 standard deviations. If I go all the way to here, it'd be 95%.
So
But-
what are you talking about? Is it not 2 standard
So we
deviations?
gotta subtract that.
one.
Madison, it's 2 below, but 74 is only 1 above.
We subtract
I think you should
13.5
sit.
from that.
So if you can remember, hey, listen, stop. If you can remember that that's 13.5 right here, then 95 minus 13.5 would give it to you. We could also remember what's between 1 standard deviation below and 1 above.
31.
But 1 is how much? 68%. And then I can figure out what that's 2 standard deviations below is. And so I think you come out with 81.5%.
Yeah.
So it's just playing around with that. Alright, try to get B done. We'll wrap up in 2 minutes.
Oh my.
So try to get B done. Hold on a second. Be careful. That's not what that problem says. Between 62 and what?
The bottom is.
62. What'd you go to?
I thought he was trying to do 13, I was like,
But I didn't, because remember I was pointing out between 2 below and 2 above is 95%. I needed to take out that 13.5 from the 95%. That's how we got this, right? Between here and here is 95%. You take out that 13.5, we have 81.5.
So that means they go.
But you're not even explaining. Y'all doing real.
Yes.
They just be going, not explaining what they doing. And then I'm just sitting here, they don't know write it down, it's a problem.
13 was.
At this point, it's not even a group discussion, it's an individual. We're not doing
Okay, well, let's be more careful and intentional about being a group here.
yeah, we need that,
Don't sneeze on me.
2.5.
Yeah, 62 and 7, 2 standard deviations below and 1 above. We're breaking down that empirical rule to figure out what that percentage is. Right, so what I pointed out is between -2 below and 2 above, that's at 95%. And so if you can remember then, okay, this is 13.5, 95 minus that 13.5 gives us this section, 81.5.
We do the same thing here, right?
It was a similar breakdown. Hold on 1 second, Gabby, just because we only have a minute, then I'll talk with you. Okay. Alright, we will pick up tomorrow with this. You have a little bit of time to pack up, so pay attention to the or the wrap-up slide. Listen, no practice assignment today. Take a break. You will probably have a practice assignment tomorrow. Tomorrow we're going to wrap up this empirical rule work, so 2.2 and 2.3, and then we're going to move into the next lesson, z-scores and percentiles. If you need to talk, stay and talk to me and ask a question or two after class, do that. Go ahead and pack up. One group or one member per group, grab the rulers and put them back over here. One person per group, grab the calculators, put them up. Make sure you grab your name cards and put them in your notebook.